Towards Blockchain 3.0, codifying Ostrom principles on blockchain to end the tragedy of the commons. The tragedy of the commons. The world has enjoyed an explosion of wealth over the last 200 years that has largely been driven by the rise of corporations. Corporations have a fractional ownership model which allows capital to be raised for large-scale projects. They scale better, which enables the development of specialised skills and provides economic efficiencies. And complex projects, higher skills and cheaper products are significant factors in our society's wealth. In contrast, commons business models such as cooperatives have struggled to produce the same levels of wealth. And this is because individuals who act in their own short-term self-interest behave contrary to the common good of all users, including their own. Hardin termed this phenomenon the tragedy of the commons. When combined, two relatively recent developments change this, and they can drive mass human abundance at the same levels as corporations and stock markets have over the last 200 years. In 2009, Ostrom won the Nobel Prize in Economics for demonstrating that the tragedy of the commons does not need to occur if 8 principles or rules are present in the design of the governance of the shared resource or decentralized organization. In 2008, Satoshi Nakamoto invented the cryptocurrency Bitcoin and its primary innovation, blockchain technology. Blockchain allows Ostrom's principles to scale beyond the limits of human personal relationships, enabling the creation and operation of efficient, decentralized, autonomous organizations, or DAOs, that bypass today's rent-taking institutions and redistribute the rewards of economic efficiencies to those who use its services. DAOs, dApps, and other blockchain concepts. Bitcoin was the first blockchain platform. It and others like it are often categorized as blockchain 1.0. These cryptocurrencies operate primarily within the crypto economy. They have very little interface with the real economy, and they are coded within what is called the fabric layer of the blockchain. The next innovation that came along was Ethereum. It and others like it are categorized as blockchain 2.0 platforms. Their innovation is that they allow other applications called dApps and decentralized organizations to be coded on their application layer as programs. What we're seeing now is the emergence of blockchain 3.0 platforms. They have services built into the fabric layer which the application layer applications can call upon. These services are typically governance services that allow the blockchain to self-evolve and self-innovate. And this will allow these blockchains to interface with the real world economy. And another concept is called futarchy, which Hansen described as one where members vote on values and bet on beliefs. Hansen observed that prediction markets or betting markets are consistently better at predicting outcomes than experts. He proposed a model where communities vote on what they actually want and prediction markets decide how best to obtain the desired results. He was primarily focused on sovereign governments. However, Vitalik Buterin came along and he considered implementing predictions markets and voting as an application and using futarchy as a means of governing Ethereum. The Tezos blockchain, which is a very new blockchain, has already integrated voting and automated blockchain upgrades within its fabric layer, and it is proposing to add a predictions market so that a futarchy can optimally cause it to innovate. Futarchy will decide what. This project was concerned with investigating the feasibility of codifying commons governance design principles on blockchain technology so that scalable and efficient peer-to-peer businesses and cooperatives could operate as decentralized autonomous organizations. We used Ostrom's principles to analyze existing blockchain platforms. We used the principles to determine the presence, absence, and optimality of Ostrom's rules in the design of Bitcoin, Ethereum, DAOs hosted on Ethereum, and Tezos with Futaki. The use of Ostrom's rules to analyze Bitcoin was quite enlightening. It showed that as Bitcoin primarily operates within the crypto economy, it requires a relatively simple design to achieve alignment with Ostrom's rules. And it has achieved this, and arguably this is a significant reason for its success. However, the analysis also showed that it has two significant gaps. The first is that it lacks specific features, and this is causing potential members to use other blockchains. And two, it lacks a structured governance mechanism, and this is preventing Bitcoin from evolving to meet the needs of a larger group of members. The Bitcoin developer community are proposing sidechains, which are other blockchains integrated into the Bitcoin blockchain, and off-chain layer 2 applications as a means of solving the feature gaps. It is arguable that as these allow Bitcoin to retain alignment with Ostrom's rules, that Bitcoin will likely cement its position as an alternate form of money, but also that governance and architectural issues will prevent Bitcoin from evolving into a platform that will successfully. We also used Ostrom's rules to analyze Ethereum as a DAO and DAOs operating on Ethereum as an application. As a DAO, Ethereum also primarily operates within the crypto economy and as such has similar levels of alignment with Ostrom's rules as does Bitcoin. And although it has additional features, it also has similar gaps. Hosted DAOs on Ethereum leverage decentralized apps also hosted on Ethereum, and these provide some of the features required by them to be aligned with Ostrom's rules. However, this model introduces significant complexity, and the sum of this complexity and supporting dApps misalignment with Ostrom's rules results in DAOs that are in themselves non-compliant. Arguably, this explains why Ethereum-based DAOs have not yet been successful. The Ethereum developer community is large and diverse. They are focusing on both fabric layer upgrades and application layer add-ons to resolve feature gaps such as scalability and governance. However, it is arguable that architectural complexity and governance issues will prohibit real-world interfacing DAOs from successfully operating on Ethereum. Tezos is a blockchain that was launched in September 2018, and it's a blockchain 3.0 candidate. When considered by itself as a DAO, it's similar to Bitcoin and Ethereum in its alignment with Ostrom's rules, even though it does have some better features. However, as a real-world interfacing DAO hosting platform, it has services that provide functions that allow DAOs to be built in alignment with Ostrom's principles, and these are integrated within the fabric layer and are in themselves better aligned with the principles. They're also less complex. Governance is inbuilt within Tezos, and this will drive optimal features and architecture upgrades required by DAOs. However, it seems that there is a gap. It is arguable that proof of member individuality is required for governance and Futaki to be successful. One of Ostrom's rules is that the boundaries of an organization needs to be clearly defined, and it's difficult to clearly define those boundaries when you don't know who is interfacing with it. The Tezos community is currently focusing on. So what were the conclusions of the project? Firstly, in the literature review that was conducted at the beginning of the project, there were no discovered academic literature that used Ostrom's rules to analyse blockchain technology, and we believe this is a first. Secondly, the use of Ostrom's rules shone new light on blockchain technology's immaturity, potential, and it provides a guide for blockchain practitioners to design blockchains so that they can fulfill their potential. Thirdly, although futarchy is in theory an optimal means of identifying and implementing the changes a blockchain must undertake to meet the needs of a DAO, futarchy in itself depends on the establishment of proof of individuality prior to its implementation, and this is a gap in the current blockchain 3.0 candidate's design. 4. DAOs that operate or interface with the real-world economy and the DAOs and dApps and the underlying blockchain technology they leverage should all be aligned with Ostrom's rules for DAOs to be successful. Additionally, the research suggests that many of the features required of DAOs are best implemented in the fabric layer of a blockchain as a service. This will reduce complexity and it will provide a mechanism to decentrally bootstrap the DAO and provide incentivization for participation. Further research into this is recommended.